going on, Alex Bros? In this video, what I'm going to do is show you how to work with the more general version of the compound interest formula. This is something that we saw just sort of on a smaller scale back in chapter 11, where we were trying to compute the amount of a loan or an investment um, compounded annually. So interest was compounded at the end of each year during the total number of years that the loan or investment was out for. Um, the more generalized version of the compound interest formula is given at the top of the screen here. A equals P, quantity 1 plus R over N, and then that quantity raised to the power of N times T. So this is definitely exponential in nature. And the major difference between this formula and the one we worked with back in chapter 11 is that we're seeing this variable N in there. So we have the interest rate being divided by n, and in the exponent here, or the power, we have n being multiplied to t. And so what this n stands for is the number of times interest is compounded in a year. So this formula handles the case where, throughout each year that the loan or the investment is out for, interest is being compounded within each of those years. So here we have an example where it says use the formula, the compound interest formula, to find the amount owed at the end of 10 years if 16,000 is borrowed at a rate of 5% compounded monthly. All right, so the instructions are a little bit different than before. Back in chapter 11, it gave us compounded annually. But now what we're saying is instead of computing interest at the end of each year, what we're going to do is compute interest at the end of each month over the period of 10 years. So let's get started. Let's figure out what we know and what we don't know. It says find the amount owed. So that would be speaking to the variable a. Make a little laundry list here. A equals, well, I don't know. That's actually what we're in the interest of finding here, no pun intended. But at the end of 10 years, so this is a particular value of t, if 16,000 is borrowed, so that's a starting amount. In other words, it could be serving as a principal or a value for P, and it's borrowed at the rate of 5% compounded monthly. So 5% is going to be our rate R, and compounded monthly means that it's going to be, interest is going to be calculated 12 times throughout each year. All right, so let's continue this little laundry list off to the side. We have P, I'll write out next, which is 16,000. R is 5%, but we know we want that in decimal format, 0.05. We do have a value of n in this case, it's 12. And then we have a value of t, which is 10. All right, just a side note here, n can vary. It could say something like compounded weekly, in which case n would turn into 52 since there are 52 weeks in a year. Interest could be compounded daily, such as the case with credit card companies and how they compute interest on your credit card balance, in which case n would be 365. We're going to look later on in this chapter the case where interest is compounded at all moments of time, in which case it would be called continuous interest. Another side note here is that the value of t always needs to be in years, right? Okay, so what are we going to do with this information? Well, we're going to plug it into our compound interest formula. A equals, our value of P is 16,000. Now open up that set of parentheses. We're going to write 1 plus decimal version of the rate, 0.05 divided by 12. And we're going to make a power on this quantity here, and that power is going to be 12 times 10. So this is definitely something I encourage you to type into your calculator, but before you do so, I recommend maybe grinding out the multiplication that's part of that exponent on this expression that I'm writing out right now. In other words, let's go ahead and multiply 12 times 10 to get 120. So a couple of things before this gets punched in, which I'll have you guys do. I'll provide the answer, of course. Is that each time that the interest is being calculated, it's not using 5%, but rather it's using 5% divided by 12. All right, so basically at the end of each month, the balance here is getting charged 0.05 divided by 12%. And notice that the power on this quantity here is 120. Hopefully that makes sense because throughout a period of 10 years, if interest is being calculated at the end of each month, and there are 12 months in a year, then the total number of times that interest is calculated realistically is 12 times 10, or in other words, 120. So just a couple of things that I felt are noteworthy to include in this video. But what you want to do is go ahead and enter this into your calculator, and we'll round to the nearest penny. This should give you 26,352.15. So under all these conditions, if there is, let's see, 16,000 borrowed at a rate of 5% compounded monthly, and we have this borrowed for a total of 10 years, then the amount owed is almost, or actually a little over 10 grand more than what we started out with, $26,000 or $26,352.15. All right, so hopefully everything I mentioned in here makes sense. If not, feel free to reach out to me. Otherwise, thanks for watching the video, and I'll see you guys soon.